Hello and welcome to our 9th video on angles. I'm Mr. Chowdhury and today we're going to be looking at angles in polygons. Now if you haven't already watched our angle facts rules, I suggest you go and watch those first before you come and watch this one. But if you have, here's your first task. I'm going to give you a bit of information about this diagram. So the information I'm going to give you is the following, that these three angles are called A, B and C. What I'd like you to do is write down as much as you can about what you can tell me about this diagram. What other angles do you know? Why do you know those angles? And we'll go from there. Pause the video and have a go at that, please. Okay, so here's the first thing that you should have noticed. A, B and C must sum to 180 because A, B and C are on a straight line. And angles on a straight line sum to 180. What else we know is that since this angle here is A, this angle here is also A because it is opposite angle A, and opposite angles are equal. We also can see that we have a set of parallel lines and a transversal that goes through them. Therefore, this angle in the corner here in the bottom is also A because alternate angles are the same. So we've got this angle which is also A. Now we've got an angle B here, and we know that this angle is also B because they are opposite, and opposite angles are equal. Last one with angle C. We know this is angle C, therefore this angle is also angle C because they are opposite. We have our set of parallel lines and our transversal. Therefore this angle here in the corner is also C because alternate angles are equal. So now we've got these three angles inside this shape, and that shape is a triangle. So I've got angle A, angle B and angle C inside a triangle. And I know that A, B and C equal 180. That means we've just proven that interior angles in a triangle sum to 180. Now I'm sure that's a fact you already knew, but this is the proof behind that fact, and it's going to come in useful as we go through this lesson. Okay, so let's continue. You are going to fill in this table using the names of shapes here. You're going to try and fill in this table using the name of shapes here. So pause the video, have a go at filling in this table, and we'll come back in a second. Okay, so you've had enough time to have a go at this. So a three-sided shape is called a triangle. A four-sided shape is a quadrilateral. A five-sided shape is a pentagon. 6 sides for a hexagon, 7 sides for a heptagon, 8 sides for an octagon, 9 sides for a nonagon, and 10 sides for a decagon. Now here's your next question that you need to have a go at. What does a regular shape mean? What do we mean by the word regular? A regular shape, can you define it? Pause the video and have a go at that. Okay, so let's define the word regular. A regular shape is a shape where all the sides and angles are equal. So all the sides and angles have the same value. They are exactly the same. Okay, so let's move on. Using the information we've already learnt, angles in a triangle sum up to 180. A regular shape is where all the angles and sides are equal. We're going to be working with regular shapes to begin with, but what we learn about regular shapes later on, we can apply them to any shape. So here is your first shape that we're going to look at. What can you tell me about angles A, B and C? Pause the video, have a go at that. Okay, so you should have noticed the following things. That all of the angles are the same since this shape is an equilateral triangle. Now equilateral triangles are a type of regular shape, and we know this is an equilateral triangle by these little lines that denote that each of these sides is the same length. So we know that all three sides are the same length, which makes it an equilateral triangle. And since an equilateral triangle is a regular shape, we know regular shapes have the same size sides and angles. They are all equal. So what value are each of these angles? So we know A, B and C are the same, but what's the value of A, B and C? Well, we know that the sum of interior angles is 180 degrees. And if we divide that by the number of angles we have, so we do 180 divided by 3 because we have 3 angles, we get 60. So each one of these angles is 60 degrees. We know that the interior angles of a equilateral triangle are 60 degrees. Now let's have a look at this shape. What can you tell me about this shape? Pause the video, have a go at that please. Okay, so we know this shape is a square, and the reason we know this is because it's a regular quadrilateral. And we can see this because we have these lines which tell us that each of the sides are the same length. And we know that inside a square, all of the angles are 90 degrees. That's a fact that you would have learned before. So that's something that we already know. But why are they all 90 degrees? And this is why. We can take this square and we can split it into two triangles. So there we go. I split it into two triangles. And because I've split it into two triangles, that means each individual triangle, the angles in the individual triangles sum to 180. So if I've got two triangles that have angles that sum to 180, if I want to count all of the angles together, the sum of interior angles for a quadrilateral must be 360, because I've got 180 add 180. So then if all of the angles add up to 360 and I've got four angles which are equal, because this is a regular shape, I can do the sum of interior angles, which is 360, divided by 4, which is the number of angles I have, and I get each one to be 90. So this is the proof of why quadrilaterals have, a regular quadrilateral, sorry, have angles which are 90 degrees. So squares have angles which are 90 degrees. Right, here's a pentagon I'd like you to think about. What could we do to help us work out the sum of interior angles for this? Pause the video and have a look. Okay, so the one thing we can do is use shapes we already know the angles for to help us work this one out. So the one shape we know the angles for is triangle. So we're going to try and split this pentagon into the least number of triangles. Now you may be asking, how do we split a pentagon into the least number of triangles? Well, this is how you do it. You pick a corner. So you pick a corner. So I've picked this corner there and I put a little pink dot there. And what I'm going to do is I'm going to join that corner to every corner it's not already joined to. So I'm going to join that corner to every corner it's not already joined to. So let's have a look at this top corner here. It's already joined to that by a line, so I don't need to draw another line to join them. So then we'll look at this corner opposite it. It's not joined to that with a line, so I'm going to draw a line to join them together. Let's look at this corner in the bottom. It's not joined to the original corner with a line, so I'm going to draw a line to join them. And our final corner, it's already joined, so we don't need to do it. And what I've done now is split this pentagon into triangles, and that I can do that with any shape, regardless of what shape I have. All I want to do is pick a corner and then join it to every corner it's not already joined to, and that way I will have the least amount of triangles I can have. So I've got 3 triangles here, and each triangle, the angles sum to 180. So I've got 3 triangles where the angles sum to 180. So all of the angles together, the sum of all the angles, is going to be 180 add 180 add 180, which gives me 540. So it's basically 180 times 3. Now that's all of the angles must add to 540. Now this is a regular pentagon. This is a regular pentagon, and the way we can find out what each individual angle is by doing 540 divided by 5, because that's the number of angles inside a pentagon. So we know the interior angles of a regular pentagon is 108 degrees. Now, here is your task. You will look at each of the shapes that we looked at earlier, and you will tell me the number of triangles inside that shape. Then you're going to look at the sum of interior angles of that shape, and then what each individual angle is within that shape. There will be a little pattern, so you will probably notice that and be able to fill in things a bit quicker. But if you don't notice the pattern, it's not the end of the world. I'll do the first couple for you. So what I've done is I've put the names in, and I've done the first 3 shapes for you. Just filled in the first 3 rows of our table. So we already did triangle. We knew it was 180. The sum of interior angles was 180, and the interior angle was 60. We did a square or a quadrilateral where we knew that there were 2 triangles within quadrilaterals, or the square, the regular quadrilateral. The sum of interior angles 360 and the interior angles were 90. We just did a regular pentagon where there were 3 triangles. The sum of interior angles was 540 and each interior angle was 108. You're starting to see a pattern now. What I'd like you to do is spend some time, probably take you about 5-10 minutes, to complete the rest of this table. Now the bottom one where it says N, what you need to do now is, once you've figured out the pattern, is try and generalize what that pattern is going to be. So write some sort of algebraic expression to help you find any shape, regardless of how many sides it has, the sum of interior angles and the interior angles for any shape, as long as it's regular. So go off, pause the video and have a go at that, and we'll come back with the answers in a second. Okay, so now let's have a look at some of these answers. So here are all of the answers, and I'll talk you through all of them. So the number of triangles for a hexagon is 4, heptagon is 5, octagon is 6, nonagon is 7, decagon is 8. So we can see that the number of triangles increases by 1 as the number of sides increases by 1. So an 11-sided shape would have 9 triangles in it. The interior angles for a hexagon is 720, heptagon is 900, octagon is 1080, a nonagon is 1260, and a decagon is 1440. And we can see that as the number of sides increases, the sum of interior angles increases by 180. So the difference between 540 and 720 is 180, and so on as we go down. Now the interior angles, the pattern is a little bit harder to spot, but as the number of sides gets bigger, the angle also gets bigger. That's what we're looking at. There isn't a set increase, but that's what's happening here. So let's have a look at the generalization. So a triangle has 3 sides, and there's 1 triangle inside there. A square has 4 sides, and there are 2 triangles. A pentagon has 5 sides, and there are 3 triangles. Are you starting to see the pattern? Hexagon has 6 sides, and there are 4 triangles. So we can see that the number of triangles is 2 less than the number of sides, and that's why I've written n minus 2. So the number of sides is n, and the number of triangles would be the sides minus 2. So for example, for a decagon, 10 minus 2 is 8, and we can see in a decagon there are 8 triangles. And that's how I worked out how to work out the number of triangles. Now the sum of interior angles is even simpler. So all I'm doing is looking at the number of triangles and multiplying it by 180. So 180 times 2 is 360. 180 times 3 is 540. 180 times 4 is 720, and so on as we go through. So the generalization would be n minus 2, which is how we work out the number of triangles, and you just multiply that by 180. So if I had a 50-sided shape, I know that a 50-sided shape would have 48 triangles, and each individual, and the sum of interior angles would be 48 times 180, right? And now the interior angles is even simpler. Once we know the sum of interior angles, we just divide it by the number of sides, and that's why I've written n minus 2, which gives us the number of triangles, times 180, which gives us the sum of interior angles, divided by the number of sides, which is n. And hopefully that's how you can apply it to any shape. And we can apply this to any shape. So if we had a 20-sided shape, the number of triangles would be 20 minus 2, which is 18. That tells us the number of triangles is 18. The sum of interior angles would be 18 times 180. So you do 18 times 180, and that will give you 3,240. And then we divide that by the number of angles, which is 20, and we know that each individual angle would be 162 degrees. And we can do that for any regular shape. And once we know what the sum of interior angles is for a regular shape, it would be exactly the same for an irregular shape. So all hexagons the angles in all hexagons would sum to 720. The angles in all octagons would sum to 1080, and so on and so forth. Now hopefully that's been helpful. What I suggest now is you go and watch Mr. Amison's video, and that will give you a little bit of practice. If you're feeling super confident, you can go on Dr. Frost or Corbett Maths and practice some questions on your own. And go off, be productive, and I'll see you in the next video.